Sorry for the mess up. That means as x goes to negative infinity, so on the left, our graph is pointing up, and so our f of x values would be positive infinity. Now, when you do your practice, this can be written backwards, which is a little bit confusing. So if Delta Math wanted to, which it does sometimes, for some reason it starts off with your f of x value or your y value first. And then it'll put your x value second. So for example, this is the same thing written backwards. And Delta Math will do that. Some tests will do that. Just know they can be used interchangeably. All right. Enough about end behavior. Just kidding, more end behavior. So the end behavior of a cubic is totally determined by the leading coefficient. So if you find the leading coefficient, you immediately know the end behavior. So if your leading coefficient, or the number in front, is positive, your graph is going to go up. That means your cubic function will go up. And then that means our end behavior answer is what we did on the previous page. It is always this for my end behavior answer. If your leading coefficient is negative, it's going to go down, meaning your cubic is sliding down a nice little hill. And then therefore your end behavior will always be the following, right here. So that is always the answer to a cubic's end behavior. And they will always be opposite because cubics go opposite ways. All right, now enough about end behavior. So I want you guys to try example 1 and example 2. In example 1, you're going to match the equations to the graphs. And then on example 2, you are going to figure out the end behavior. Now, all of that's without a calculator, so you may need to visualize, is my graph going up, is my graph going down, to figure out the end behavior. So sketching a graph could help you out. But try number 1 and number 2, and press pause, and we will go over the answer. All right. Thank you for pressing pause. So in our problem, number 1 is a cubic function. So I need to either pick A or D. Number 1 is going up, so it is positive. It should be A. Number 2 is going down because it's negative. Therefore, it is the cubic D. Cool. 3 and 4 were a throwback. They are quadratics. 3 is negative, so it should open down. Therefore, it is graph B because it is a quadratic and it's negative. On 4, 2 is a quadratic. Going up, positive, would make it graph C. So that's kind of a way you can look at the leading coefficient to tell you if it's going to open up or down. Now on number 2, a little tricky, you first have to make sure it's in order. So this goes 3, 2, 1, no variable. So this graph is in order, meaning that my cubic is going to be going down because your leading coefficient is negative. So if your graph goes down, roughly looks like this, and then that is my answer to my end behavior. As x goes to positive infinity, your f of x is negative because it's going down. As x goes to negative infinity on the left, your f of x or y values are going up. The middle one was super tricky because if you don't put it in order, you are going to miss the leading coefficient. So this one is actually positive, so it's going to be going up. So my end behavior is a little bit flipped. This one, I wrote it backwards for fun. Why not? As x goes to negative infinity, your f of x is negative infinity, positive infinity, positive infinity. Again, you can have them rewritten in different order. Backwards, it is all still correct. H of x was actually not a cubic, it is a quadratic, and it is positive for leading coefficient, so your graph will go up, therefore leaving our end behavior as the following. Both positive infinity for your y values or f of x values. Okay? So for end behavior, most important thing, make sure you either put it in order or look for the leading coefficient. Figure out if the leading coefficient is negative or positive, and then write your end behavior. All right, Let me know if you have any questions. Moving on. All right, our second goal today is to determine all the key characteristics of cubics. Now, you've done this with quadratics. It is a little bit harder with cubics just because it's more information, but it's the same information, just more and more and more. So let's talk about it. List any relative maximums. So maximums would mean high point. It is relative because if I am tracing this cubic, it relatively has a peak right here, but then it goes back down. So it's not why it's not called a max, because it technically is never ending. It's going up and up and up and up and up. But the relative max would be like the little bitty hill, which would be right here at the point 0, -2. So that would be one of the relative maximums. A relative minimum, again, this graph is going forever down. That's why it's not just called a minimum, but it peaks and then it dips at this point right down here, which would be -1.3 to 3, -3.185. So relative max and mins are kind of like the little hills or roller coasters of your cubic. Now, domain has always been all real numbers. It will continue to be all real numbers because this graph is going forever left, forever right. So forever, all real numbers. Fun fact, range, this graph is going forever up, forever down. So hey, cubics are going to have all real numbers for both domain and range, which is quite nice. Let's go ahead and talk about end behavior because we've been focusing on that. So end behavior, let's start with as x goes to -infinity, because why not? As x goes to -infinity, that means the left side. So what is my left arrow doing? My left arrow is pointing down. Therefore, my f of x value would be -infinity. My end behavior for the right side. So let's check as x goes to positive infinity. On the positive infinity, on the right side, my arrow is pointing up. Therefore, my end behavior would be a positive infinity. All right. So the next question says, what is the average rate of change between x equals -1 and x equals 0? So if you'll remember from the last module, average rate of change is slope. And so it's our formula, y2 minus y1 over x2 minus x1. So I need two order pairs to get that slope formula. And it gives you your x value. You just have to go find your y value. So in this graph, I go to -1, and then I need to figure out my y value. So at -1, my value is a -5. So that is my first order pair, a -1, comma, a -5. Then I'm going to go find my x value at a 0. So where x is 0, I have to go down to my graph to find the value of a -2. And so my second point is going to be 0, -2. So then I'm going to take those 2 points and then plug them into my formula over here. So y2 is going to be -2. Minus is always in your formula. Your y1 is going to be -5. So I would have -2 minus -5. Over, my x2 would be 0 minus a -1. So if you're dealing with negatives, you could have a minus, which we do know that two negatives are going to turn into a positive. So I can actually combine those two negatives and turn it into a big plus sign to help me simplify. So now I'm going to simplify the numerator. So this essentially is a 5 minus a 2, which is a 3. And then 1 plus 0, which is a 1. Then I'm going to do 3 divided by 1 to get a 3. I cannot talk right now, so sorry. And I can't pause it because it messes up. I'm so sorry. Okay. 3 divided by 1 is 3. So that is going to be our average rate of change for this lovely problem. Okie doke. 4 more. Increasing. So again, back to our last module, increasing means going up. So if I trace this graph with my finger, let's see where the graph is increasing. So if I start down here, this graph is going up all the way until its first max. Then it goes back down, and then it is going back up. So I have 2 answers where my graph is increasing, which is new for a cubic. So my answer will have 2 answers. Again, when you're talking about increasing and decreasing, we only care about the x values. So the first part is when x is less than, and then what number is this x value? It's actually a 0. So it's when x is less than 0. Everyone wants to say -2, but that's the y value. So that is the first answer. There is a second answer. When we had quadratics, we wrote the word or. Now we're going to write the word and. So I have this answer and this answer. It also starts to increase right here at a 1.333, because that's our x value, all the way to forever. Okay? So that would be when our x is greater than, because it's on the right side, of the 1.333. So increasing, decreasing for cubics definitely gets a little bit more challenging because there is more than one answer versus a quadratic. All right. So if it is increasing on those 2 intervals, that means it's decreasing between those 2 numbers. So let's change it to pink. Oh, pink. Green it is. So it is decreasing between this interval right here. Now, since it was between 2 numbers, we need to write between in math. Between in math, we put an x in the middle. It is between the number, again, 0, because that's our x value, all the way to this other x value of 1.333. So increasing and decreasing now looks a little like how we've been writing positive and negative in Module 2. All right, let's talk about positive and negatives now. Go ahead and erase this. So they're going to write a new terminology because we're leveling up. They're not going to say when is the graph positive anymore. They're going to say when is f of x greater than 0. So that is a fancy way of saying when is your function above 0, and it's above 0 when it's positive. So let's see where this graph is above the x-axis. We'll go yellow. So it's all negative down here, and it is positive right there. So it's positive 1 time. So I have 1 answer. Again, I only care about my x values. This x value would be the 2.359. And then ask yourself, is it to the left or to the right of that? It is to the right of it. So it is x greater than 2.359. So it is positive for all x values to the right of that number. The next question, where is the graph negative? So negative would mean below the x-axis. So below would be all of this. So it's still the same number. It's still that x-intercept where it switches. You have to ask yourself, is it to the left or to the right? So it is to the left of that number. Therefore, it is when x is less than your x-intercept. Okay? So, characteristics of cubics definitely gets a little bit harder just because you got more curves on it. Okay? All right. Thank you for watching part 2. Sorry for the mess up in there. This one is 3 parts just because this stuff's a little tricky. So, one more part. Thanks for watching. Bye!